things. Yeah.
That's a great idea. I can write 3 to 4 custom opening lines tailored exactly to your Slush talk that you can just pick from or tweak. I'm so sorry, not sure how that got in here. Anyway, I've kind of had it with these large language models. So today we want to discuss a new class of AI models that are deeply rooted in space and time. A new era of AI, if you will so, that's not only book smart, but street smart. And think about it, we trained the world's most powerful models on written words. And it was a decent starting point. It was readily available data. And to be clear, language is this indispensable tool for humanity and society, but it's ultimately also just a lossy abstraction of the real world and our being in the world. If I say the word slush, like what comes to mind for you? This venue, the talks, or maybe the friends you met in between? It's not often quite clear. Human intelligence also far exceeds the origin of language. In fact, for 2/3 of our existence, we didn't even have language. And to really think about where human intelligence came from, it probably emerged over millennia of action and intent, acting out these things in unbounded environments, collecting feedback, and seeing the consequences of our actions. And so I'd like you to invite to really think about human and animal learning. You know, like toddlers learning to walk or monkeys learning to climb trees, like trying yourself out, messing around, understanding your limits, often in a very playful way. Doing more of what works, doing less of what doesn't. It's really not how we train machines today. And so we here on stage think that building superintelligence, it isn't just about scaling data and compute. It might ultimately require a fundamentally different approach to AI, teaching machines to truly play and explore. And truly intelligent machines, they probably must move, as this talk says, from words to worlds, and acquire this capacity to perceive, to anticipate, to improvise. And I'll be honest, we could not have better panelists here with us today. John Hanke, founder and CEO of Niantic Spatial. He was previously VP at Google, where he led Google Earth, Google Maps, and Street View. Early in his career, he also created one of the first massively multiplayer online video games, Meridian 59. And his company, Niantic Spatial, is building a living model of the world that people and machines can talk to. Niantic, of course, has a rich history in spatial computing and AR, best known for Pokemon Go. That games part of the business was sold for $3.8 billion earlier this year. I think that's worth a round of applause. And Niantic Spatial still has 200 people, a very focused team, $270 million in funding to basically now build new kind of maps that AI can talk to. And then we have Pim de Witte, co-founder and CEO of General Intuition. Previously founded Metal, the largest platform for capturing and sharing gaming moments. About 10 million monthly active users, billions of gameplay clips every year. Fun fact, at age 14, he started the largest RuneScape server in the world. I don't know if we have any RuneScape players here. And just to make millions before he even turned 18 years old. His company, General Intuition, builds models for environments that require deep spatial and temporal reasoning. He recently raised over $130 million. It's actually Khosla Ventures' largest seed bet since their check into OpenAI in 2018. That's probably worth a round of applause as well. And with that, we'll dive right in. We'll start with you, John. I want to ground us in the real world. Like, take us back to this original idea for Niantic and maybe Pokemon Go as well.
I mean, it was. We just wanted to have some fun and encourage people to go outside and explore a little bit, get some exercise, have fun with their kids or their friends. That was really the mission. And that was kind of the unifying thing that, if you all are founders, it helps to have a mission like that your team can get behind, that people, feel good about what they're doing every day. So that's what did it for us.
What is it about being in the world? I know you like to take walks as well,
I mean, I think it's deeply part of our, human DNA in terms of we're evolved to know how to navigate really complex situations, like the layout of this conference center. Our brains just do that very naturally, but it's incredibly complicated. And when you start trying to program robots to just navigate a simple path, much less understand all the content of the world and what other people and things might be doing in the world, we're really terrible at it right now, which is why I'm so excited about the space, because there's a ton of innovation in AI. I think if we can unleash that on robotics in the physical world, it could be transformative and significantly improve the quality of life for human beings.
And just on a high level, before we maybe go into games specifically, but play as a higher level concept, what is the role of play, and like how are physical worlds and play connected from your perspective?
You know, I don't know. How is play connected to all of this? I think it's interesting that we kind of both had gaming backgrounds. Dennis at Google, you know, had a gaming background as well. It's a great way to learn, I think, and explore new technologies. So I don't know, the connection here for me is just like that being an on-ramp to develop really nascent new tech in a place that's kind of forgiving so it can mature. And we developed technology, you know, for Pokemon Go in Niantic, the gaming company that we spun out into this new company. But it was the ability to like work in that space of games for many years that let us kind of mature it before it was really ready for any other kind of more serious application.
Yeah. I mean, it's fair to say maybe that in some ways now you kind of like refocus on your original mission, because even going back at Google, there was clearly this fascination with mapping the world. And then Pokemon Go was such a substantial success that, I don't know, maybe you got distracted a little bit or was part of the puzzle, and now you're fully focused back on that original idea. Is that fair?
Yeah, I mean, personally, I love games. I grew up, that's what encouraged me to learn how to program, because I didn't have money to buy games for my little computer, so I typed in code from online and for magazines and wrote games. So yeah, that was my entree in. But I've always loved maps too. So I grew up with National Geographic, the magazine, and the fold-out maps, and the ability to mix those things together has been a huge amount of fun and kind of the theme of the past 20 years of my life. So yeah.
I know games were instrumental to your formative years as well, and ever since. So what does gaming mean to you?
Yeah, so I grew up with Tourette's, and so for me, I struggled in school. I actually just told John, my first computer program was actually Google Earth, so maybe an applause to John for making everybody dream about the world instead of their own local cities. So for me, it was really I started my career reverse engineering RuneScape and eventually building the largest private server on RuneScape. And that led me to eventually joining Doctors Without Borders after a few years, doing something completely different, mapping related, and then started a games company again. And so as part of that, we essentially help people create these clips which has interactions with the environment as well, right? Gamers love putting these like controller overlays and things like that on top of their videos. And as a result, we have pretty much the largest data set of interactivity in three-dimensional environments. And so yeah, for us right now, the bet is really that we can take this like LLM-like bet for spatial temporal reasoning and move everything that people are currently doing in pre-training for robotics and for games into post-training.
There's also clearly a very rich history, interlinks between AI and games. Like, I mean, just to spell it out, a lot of the foundation research labs started in gaming. You mentioned Demis briefly. He was a game developer before he became a research scientist. And NVIDIA, you know, the world's highest valued company today, actually started off in gaming with GPUs and 3D calculations. You know, I think AI entered for you like maybe over the last couple of years. Like when you think about AI in gaming, like what was the impetus for transitioning now to leveraging that game data to solve AI problems, and what was the inspiration for general intuition?
Yes, so maybe it's good to start by really explaining how do like text-based language models work, right? So they generate a piece of text, then they take what they generated and they run it through the model, and then they predict the next token or the next word. That doesn't allow for any observing of the environment to change, right? So this is called autoregressive modeling. You're using the output of the model to model the next sequence. And so as a result of that, there is no sense of interaction. The environment has no way of, the generation has no way of actually adapting to its environment in real time. And that's just not how the real world works. So as humans, we invented text as this way of compressing the world around us, right? We needed to communicate what we were perceiving with each other in a common understanding. And as part of that, we compress essentially what we are perceiving down into words. And then we modeled that. And by the way, that's incredible. We modeled a compression method that we invented as humans, and we produced one of the most beautiful systems ever invented, right? And now I think what we need to do is take the lessons from how we modeled those systems and transfer them into modeling systems that actually represent interactions of how the world works. And the world is fundamentally spatial temporal, right? We perceive three-dimensional, and text isn't. And so, and games is just, the physical world just has a lack of ground truth data on three-dimensional interactions, right? And so I'll maybe explain. If you try to maybe start with like a YouTube-like data set or a video data set, you kind of have three problems. The first problem is that you need to solve, so most YouTube videos, for instance, are recorded with a mobile phone or a GoPro, and so you have to solve for pose estimation. The problem with that is that it doesn't necessarily generalize super well to every environment, so that's information loss event number one. Information loss event number two is that you don't actually have the inputs and the actions, and so as a result, you have to guess them, or you have to hire human labelers to do it. And the third is that your actual spatial temporal reasoning is largely dependent on like where your eyes are actually looking, which that those systems actually don't capture. It might perfectly capture a part of your vision, but you might be looking right when you make the decision. And so when you're playing video games, you're essentially simulating those optical dynamics with your hand because it's the only way to actually look around and do these things. And so our bet is really kind of like the weighted anthropic hard focus on code, that you can start by learning from this spatial temporal reasoning in video games and then transfer it out into other applications. And that's why we're starting in video games. And then, but because we're sort of taking the LLM bet in a way, in terms of just like large-scale pre-training on this data, the bet is that we can just get all the data that labs are getting, but we just need a lot less of it because we already have this really, really good base.
I want to unpack with both of you these terms, world model and action model, respectively, so you can mentally prepare for that. Just to paraphrase what you just said, I think a big part of this ambition is really to have machines learn like humans most likely learn through our actions in these environments, collecting the feedback from the environments, which is a data set that simply doesn't exist in the real world. We're not all running around with brain-computer interfaces to kind of measure our actions. We can measure the response in the environment, but video games are kind of like the closest thing, or simulations are the closest thing we have to human action in worlds. It just happened to be virtual worlds, but the theory is that if that can generalize, then the real world would just be n+1, so to say. But let's try and, because these are like very, I think, vague terms actually, and like terms that are used in many different ways. When you think about world models or geospatial models, John, like, how would you describe those, and why are they worth pursuing?
Yeah, the thing that we're pursuing is different than what Pim is doing, which is incredibly cool. Whenever we were preparing to sell our baby, our gaming business, Pokemon Go, we looked at the technology that we built for augmented reality, which was built on about 30 billion posed images. So these are images of the world taken by players, contributed to this common map with a lot of special metadata associated with them. And Brian, my co-founder, and I, asked ourselves, well, what if we constructed a map that was native to AI? So we're all familiar with Google Maps and Google Earth. These are products that are designed for humans to look at and understand. So they're really written for our comprehension. And AIs can kind of use those as resources, but not super effectively. So if you want AIs to be able to reason about the world and accomplish things in the world, it might be navigating a robot, it might be solving a complicated problem having to do with real things, real cities, real actions that take place in the world, that needs to be grounded in real data about the world. So we got super excited about this idea of building a new kind of map that was really made for AI, so that AIs can have that part of the brain that you alluded to earlier that we all have as humans, that's really just dedicated to understanding the world, building out maps about the world, and then reasoning about it. So we think that's a huge opportunity, and we're building that model, but it's very much about the world as it exists. It has to be accurate, or it's not useful for the kinds of problems we're trying to solve.
I think oftentimes when people use the term world model, or if you would Google that, like a lot of what comes up is also these like generative worlds. Like you're basically feeding actions into a system, and we can now do generative video creation fast enough to basically render the next frame based on the history of the video, based on the actions that you feed into the system, and effectively create video games in kind of like the truest sense of the word, games that are just videos, playable videos at this point.
Which is very cool, but different than what we're doing.
Exactly, and so I think those are world models building worlds or random worlds. What you're doing is really you want to build a model of the world, of Earth, right? So tell us a little bit more what would be possible use cases. Like what are the first products we can imagine? Are you only going to be talking to robots or us humans too?
I'm very long on robots.
Okay, short on humans.
I'm long on humans too. I'm long on robots making life better for humans. I think there's a massive opportunity for robots to improve all of our quality of life, to make our cities more livable, our streets safer. I just think there's a huge positive impact that can come from that, and we're seeing the beginnings of it. I got to visit with the founder of Starship earlier, who's doing, their robots are running here, as well as in many other countries around the world. That first wave of deployed real-world robots is out there, a few thousand of them. But if you talk to companies, like Tesla, like others in the humanoid space, they're talking about millions of robots over the next few years. And I really believe that's going to happen. Jensen Huang said it's the next, I think he said $3 trillion industry. He believes it's going to happen. So I would encourage all of you to think about, what kind of opportunities is that going to create for your businesses? What kind of impact is it going to have on your own personal life whenever this kind of labor force is really brought to the world? But I know we need cleaner cities, we need cheaper housing. There's so many things that I think that kind of resource can help us achieve. But it needs to be spatially aware and kind of geo-grounded. And we want to make our contribution to that in that way.
Awesome. A cousin, I think, of world models are action models or action policies. Pim, like what is that?
Yeah, so an action policy or an agent, as most people know it. So these agents, similarly to world models, they develop an internal understanding of interactions in the world. And they learn to, instead of predicting the next word, they predict the next action or sequence of actions. And so, for us, like one application that's interesting to talk about, for instance, is when DeepMind originally did AlphaFold, is they originally tried to get an AI to play Fold It, which is a game about protein folding to generate more data. And so what I'm personally really, really excited about the scientific application. I think if you can represent a lot of scientific problems in 3D. And if you unblock spatial temporal reasoning or an agent that's capable of spatial temporal reasoning, especially if you then pair that with real-world physical data, it's kind of the other side, right? The problem is the environment, and the solution is kind of an agent that's capable of perceiving that world and using initially also, for instance, the chain of thought reasoning from LLMs. I think you can really generalize a lot of these domains in a way that you can't generalize them today. And so I think robotics is a great application, but like long term, what really, really excites me is also the scientific application of these models.
So basically, when you have, let's assume you have the perfect data set about actions, human actions, and the world's responses to these actions, then I guess world models would basically be generating a world given the action, and then action models would be the inverse, would be generating actions given a world and given a reward function.
So maybe one way to think about it is in a world model, you essentially take in actions and you predict frames, or you might predict in other domains, but in our case, you predict frames. An action model is you take in frames and you predict actions, or you might take in frames with text conditioning. So you take in frames, text, and then predict actions. And so, and then with text, right, you can take in a text and you predict text. So this is kind of, these are the modalities, and it's a lot simpler. A lot of these are also just transformer-based models. So it sounds very complicated. I encourage everybody to read into it. It's really not. Yeah,
So why are we so obsessed with language models then?
So language led to so many incredible breakthroughs, right? Like it's how scientists collaborate, right? It is a common understanding that led to, right, physics, math, like all these fields that were built on top. And that's, I think, also why you see LLMs excelling in these types of like code domains and math domains, right? And so yeah, now it's the turn to do the rest.
To one up.
Yeah, I would add on to that. I mean, a lot of what we're doing is really building on the success that has happened, with language model development. Not to mention the $1 trillion plus of infrastructure that's being created to support the models. But one of the things we do in our Made for AI map is attach semantic content to every voxel in the mapped space using vectors that attach to these ideas in the language model sense. So that means you can have an incredibly refined understanding of the world in three-dimensional space. And that's really because of the advances of language models. But that gives a robot the kind of perception that people wouldn't have dreamed about 5 years ago. So these things are really coming together in a transformative way.
I recognize that we're abusing the founder stage for some nerd talk. Well, typically, this is reserved for founder conversations and stories of hardship. So I want to pivot to those. I'm sure, like, getting here for both of you sounds right now you're in a good spot. But I can only imagine there were probably also some lows on the way. What were some tougher times in building Niantic and building Metal and General Intuition that you can share with the audience, and maybe advice for founders and aspiring unicorn builders?
You're looking at me for the failure story. So which one do you want?
You're just wiser than the two of us. So
I mean, my favorite memory. I love meeting people who played Pokemon Go, and often people will say, "I remember when it came out, and I was at this place with my friends doing this thing, and we went out and caught Pokemon." My favorite sort of Pokemon Go recollection is we wanted to have a big festival after the game launched and get people together in real life, just because that's the spirit of the game. So we immediately started planning it after the initial launch, and we targeted July of 2017, and we really had to rush to do this. We'd never done anything at that scale before. We sold, I think, 30,000 tickets, and it turns out they sold out instantly, and when the day came, everybody came, and they came early and formed this giant queue to get into the place where we were going to have the event, in downtown Chicago, and they all got on their phone, all 30,000 of them, in this tiny little compact area, and it absolutely destroyed the cellular network across all the carriers. So when it came time to start the event, people were walking around, and I was noticing everyone sort of had this panicked look, like the game wasn't working, and it didn't work for 30,000 people. So they booed and threw things at us, threw water bottles at us, and the team worked in the background to kind of revive things, and several hours later we were able to bring the game back online. But yeah, let me tell you, like, standing up on stage in front of 30,000 people, some of whom have come halfway across the country to play a game, and it doesn't work at all, was something that, I'll never forget. But the founder story from that is, the whole team had come out. There were about 40 of us at the time, maybe 50 people, and we all were working, various aspects of the event, and we all experienced the rage of these unhappy players. We all experienced the tension of trying to find some solution to it and figuring out ways to give rebates and refunds and just talk to people. And then finally we experienced that sort of triumphant moment of like getting it sort of back online. So it was a terrible day, but it's something that in the company that became like a cornerstone of our culture, and we referred back to it, for years as this formative event where, we were tested and we kind of failed, but we rebounded from that. And you just have to have those experiences. It's going to happen. And if they're not, you're probably not trying hard enough. You're probably not pushing, taking enough risk. But it certainly feels painful in the moment.
And you can always blame Cloudflare.
Yeah, I think for me, so growing up with Tourette's, I think video games were a very special place because it was like the one place where, growing up with Tourette's, you get bullied a lot in school. It's not very fun. Video games, you don't have that problem. You can just, you can do things. You're not at a disadvantage really very much. And so I think my personal story is I think that there is a real chance that like video games are kind of like this last weird place on the internet. Kind of like, I don't know how much of you grew up on like forums and things like that, but it feels like video games are that one place where the authenticity and the weirdness is preserved. And I'm very, very scared of like what it looks like if that goes away and if people connect. It's like it also just allows people to connect between religions. It allows people to connect between personalities. Most of my friends in the world that I still have today, I actually met playing growing video games on RuneScape. And so I think for me, the very, very personal part of this mission is really investing in the games industry and the infrastructure of the games industry to make sure gaming stays weird. And I think a big part of that, is what we do is we can sort of generate sort of intuition in any object in the environment, which includes game engines, right? And so for us, I think the personal piece is really, I think nailing that to me and making sure that games have a fighting chance against feed-based algorithms and things like that is just is a deeply personal mission. Also, something else, my first seed round actually was raised at Slush, maybe close to 8 years ago, I think. It took 87, it took 6 months, a year, 87 meetings. Nobody wanted to back games companies. The thing I would say is it was really hard. We had given, I honestly, I had given my team notice already that it wasn't going to work. It was an investor, Alex from Backed, who didn't care about that, wrote the check anyways. So anyways, you just need one yes, and there are people that there are genuinely special people that just bet on people. And it's it can be pretty discouraging as a founder to go out there and tell the story 100 times and get, rejected 100 times because you don't look like the shiny thing. And then you meet one very special person or a group of special people that kind of just make it all make sense. And I would just encourage everybody sort of looking at that, right? That's just how it is. And when you look back, I think where we're at now, when you look back at those times, it's now looking at any problem in comparison to that, they look simpler. So it's keep at it, I would say.
So right.
Both prepare your one-liners for a non-obvious prediction for 2026. I'll come to you in 30 seconds. I just want to say one thing also, because we talk a lot about the similarities between human learning and machine learning and how we can maybe synchronize those more with world and action models. But there's also something magical about games and play more metaphorically here, which is a theme for both of you. It is also for me. Some people go as far to say that you really only learn, as a human, you only learn during play, when the stakes are low. It's kind of like evolution's way of keeping the expected error low while maximizing informational return. You kind of want to learn how to get up on that tree before the predator comes around. And so play is great for that. Prediction for 2026, we have 3 seconds left. John first.
Pim.
Pim.
I'll have a birthday. I'll have one birthday that year.
Okay.
In all seriousness, I think engine simulation usage up, video consumption down, interactivity up. Yeah. Go ahead.
I think we're going to see C-3PO and a real robot in 2026.
Yeah.
All right. We'll hold you accountable for that. Thank you, everyone.
Right.